Okay, so lecture 8 about division. And what we've seen recently is that if we can factor a polynomial, then you can graph it. And the previous lecture gave us two tools for finding roots. One is the intermediate value theorem, the other is the rational root theorem. Once we have found roots, we need to be able to factor them out, and that requires division. So let's do a long division problem, 1043 divided by 27. So we take 1043, put it in this rectangle thing, and we put the 27 here. So how do we do this division? Well, we need to find 27 goes into 100, doesn't go into 10, so it goes into 104. How many times does it go into 104? 104, and the answer is 3 times. 3 times 27 is 81. And then you subtract. 4 minus 1 is 3, 10 minus 8 is 2. And then we bring down the 3. Right? So how many times does 27 go into 233? Well, a lot. 27 times 10 is 270, so it's actually going to be 8. And 8 times 27 is 216. And we subtract 216 from 233, and that gives us 18. And we stop. And why do we stop? Because 18 is less than 27. So 18 is our remainder. We'll call that an R. And we can write this out in two different ways. You can say that 1043 divided by 27 is equal to 38, which is the number we got up here, plus our remainder, 18 27ths. So there's 38 27s that go into 1043. That's a 4, not a 9. And you have 18 left over, so 18 27ths. Now, if you take the 27 and multiply everything by 27, you get 1043. So if I multiply this by 27, the 27s will cancel out, equals 38 times 27. There's nothing to cancel out there. And then 18 over 27, if I multiply that by 27, I'm left with a remainder. So 1043 is 38 times 27 plus 18. And so from this, we can see that 27 is not a factor of 1043, because if it was a factor, you'd have a 0 there. Almost the same sort of thing happens for polynomials when you do long division. So I want to divide x squared minus 5x plus 6 by x minus 3. So I take my x squared minus 5x plus 6, and I put that inside of my little rectangle, and I put my x minus 3 here. So it sets up the same. It works a little bit differently. We're going to look at the leading terms here. What do I multiply x by to get an x squared? Well, I have to multiply that by an x. So if I take this x and distribute it over this, I'll get x times x is an x squared. X times minus 3 is a minus 3x. Right? That's like getting the 81 there. And then what do we always have to do? We always have to subtract. So we'll subtract this off. X squared minus x squared, that's a 0x squared. Minus 5 minus minus 3, remember that minus minus 3 is plus 3, so minus 5 plus 3 is a plus 2x. And then we'll pull down the plus 6. So we look at the leading term in our factor here, that's x. And this leading term is 2x. What do I multiply x by to get 2x? I multiply it by 2. Sorry, that should be a minus 2x. I want to multiply this by minus 2. Minus 5 plus 3 is minus 2. So if I take this, multiply by minus 2, minus 2 times an x is a minus 2x. Minus 2 times minus 3 is a plus 6. Subtract, we get 0. That's our remainder. And so we can write this in both ways. We can write it as x squared minus 5x plus 6 divided by x minus 3 equals x minus 2 plus a remainder of 0 over x minus 3. Or if we multiply through by x minus 3, we get x squared minus 5x plus 6 equals x minus 2 times x minus 3. And x minus 3 times 0 is just 0. So we factored it here, right? A remainder of 0 means that x minus 3 is a factor of this thing. X minus 2 times x minus 3 is x squared minus 5x plus 6. So if we want to factor polynomials, we just have to find things that divide it with a remainder of 0. So this is another example. This isn't actually going to get us a factorization, just another example of long division. So I'm going to want my polynomial that I'm dividing, x to the 4th. It doesn't have an x cubed term, so I'm going to include it anyway because I need a column there, right? So there's a 0x cubed in there, plus 3x squared minus 2x plus 5, and we'll bring that over a little bit. Then I want to divide it by x squared minus x plus 2. Okay, so how do I do this? I look at the leading term here, which is x squared, and the leading term here, which is x to the 4th, and I ask myself, what do I multiply the x squared by to get the x to the 4th? And I tell myself an x squared. So I'll take this x squared, and I'll distribute it to each of these terms and write it down here. X squared times x squared is x to the 4th. X squared times minus x squared minus x is a minus x cubed. X squared times 2 is a plus 2x. So get the x squared by saying, what do I multiply x squared by to get x to the 4th? That's where I got this. Got this line by multiplying the x squared times each one of these, and I subtract. So what am I left with? X to the 4th minus x to the 4th, that's a 0x to the 4th. 0 minus minus x cubed, that's a plus x cubed, and that's why we need the column for the x cubed, even though there wasn't an x cubed term. 3 minus 2 is a 1x squared, and then I pull down the remainder of the problem. Great, so now I look at the leading term here and the leading term here, and I say, what do I multiply x squared by to get x cubed? And that would be an x. So I take my x, I multiply it by each term here, distributed across, and write those answers down here. So x times x squared, that's my x cubed. X times minus x, that's a minus x squared. X times plus 2 is a plus 2x. And then we subtract. X cubed minus x cubed is a 0x cubed. That's good. We're trying to get rid of the powers. X squared minus minus x squared, that's x squared plus x squared. So that's a plus 2x squared. Minus 2 is minus 4x. And we pull down the 5. Great. What's the next step? Look at the leading term here. Look at the leading term here. What do I multiply x squared by to get 2x squared? That's by 2. 2 times this whole thing gives me 2x squared minus 2x plus 4. I need to subtract the whole thing in parentheses. 2x squared minus 2x squared is 0x squared. Minus 4 minus minus 2 is minus 4 plus 2. That's minus 2x. 5 minus 4 is plus 1. Great, so I look at the leading terms again. What do I multiply x squared by to get 2x? Ooh, I'd have to divide by x or something. So we stop here. The degree here is degree 1, that's degree 2. Since the degree here is less than the degree there, we stop. Same reason 18 is less than 27, so we stop there. You could keep going and give you decimals. But we'll stop here because this, what do I multiply x squared by to get 2x? It would be 1 over x, and I don't want to get into 1 over x's. So there's our division. Now we can write this in 2 different ways. One is our function, x to the 4th plus 3x squared minus 2x plus 5 over what we divided by, which is x squared minus x plus 2, equals what? Well, the thing we have up here, x squared plus x plus 2 plus, and that should be a 2, although that looks like a backward S, but it is actually a 2, plus our remainder is minus 2x plus 1 over x squared minus x plus 2. Like we've done before, we can multiply through by the denominator, and that gives me x to the 4th plus 3x squared minus 2x plus 5 equals x squared plus x plus 2. That's this term times that. Plus the remainder, right? When I multiply everything through by x squared minus x plus 2, this gets canceled out and left with that. So this isn't a factorization because there's a remainder, but we can do division, which is nice. Actually, division comes in handy in a lot of different places. But for us, there's something that we prefer to do called synthetic division, which is a lot faster. And if we're dividing by just a factor that's like this, x minus 3, we can do the synthetic division. So if x minus 3 is a factor, that means x equals to 3 is, or would like it to be, root. So when we're dividing in synthetic division, we actually use the root, which is 3. The factor is x minus 3. The root is x equals 3. And we put in our coefficients, 1, minus 5, and 6. This is my x squared column. This is my x to the 1st column. This is the constant column. How does this work? Well, we pull down the 1. 3 times 1, we multiply the 3 times the 1 and put the product here. And we add going down. 3 plus minus 5 is minus 2. 3 times minus 2 is minus 6. We add going down, 0. Now dividing by x minus 3, this is a first power. So if we divide a second power by a first power, then we're going to end up with a first power. So this is my x to the 1st column for my answer. My constant is the second thing, and this is my remainder. And so this is telling me that x squared minus 5x plus 6 is the factor x minus 3 times x minus 2, 3, plus 0 remainder. And this is the same thing as what we did up here, but with the numbers in a different place. So we got an x minus 2, right? So 1 minus 2, that's my x minus 2 up here. The numbers we got here were 3 and minus 6, right? There's my 3, minus is a 3, minus 6 there. So this 3 and the 6, or this 3 and the 6. So it's doing the same thing, it's just organized in a nice manner, and you can do this whenever we do, whenever you're just dividing by like x minus 3 or x minus 2 or something like that. So what is f of 3? What does this give us? Oops, let's put that up here so it's not going to bother us too much. So if our function is f of x equals to x squared minus 5x plus 6, what our division has done is said that we now have a different way to write it. We can write it as x minus 3 times x minus 2. And from this, if we say, well, what's f of 3? It's a terrible 3. Well, we can tell right away that that's 0, because if I plug in 3 here, I get 3 minus 3, and that's 0. And whatever I get here, I don't care, because 0 times 3 is 0. So note that the remainder is the same thing as you get when you plug in 3 into that. So that's pretty nice. So here, again, if this is my factor, the root is equal to 2, and I want to be able to divide. I've got 1, 3, 0, minus 2. That's my x cubed term. 3x squared. There's no x to the 1st, so we put a 0 there, but we need to have a column for it, and that's my constant. So how does synthetic division work? Bring down the 1. 2 times 1 is 2, put the product there. Add going down, 3 plus 2 is 5. 2 times 5 is 10. Add going down, that gives me 10. 2 times 10 is 20. Add going down, that gives me minus 18. So what are these numbers? Well, division knocks off 1 power. Right? So this is the x squared, the x to the first, the constant, and then that's the remainder. So what are we getting? We're getting x cubed plus 3x squared minus 2 is the root that goes with this factor. So that's the x minus 2. Right? That's this. Oops, shouldn't have just gone through that. Times 1x squared plus 5x plus 10, and then minus the remainder, which is 18. So if this is all the function f of x, there's 2 different ways to write it. One is like this, one is like this. Not really factored form here because we've got a remainder. But what is f of 2? Well, if we plug in 2 into here, we'll get something messy and you have to calculate that out. If we plug in 2 into here, this becomes 0, right? 2 minus 2 is 0. So I don't care what's in there. This whole thing is 0, and I just get minus 18. So when dividing a polynomial by a factor x minus r, the remainder is f of r. So f of 2, we divide it by x minus 2. The root is 2, so f of 2 is minus 18. If the remainder is 0, then we've got ourselves an x-intercept, right? So x equals 3 is an x-intercept. So here's a function. Oops, didn't want to do that. It's a cubic. We want to be able to factor it and graph it. Right? So how do you factor cubics? Well, suppose we know that 1 is a root, and so we can use synthetic division to find the others. So if I know 1 is a root, that means that, it's supposed to be an arrow, x minus 1 is a factor. And what I want to do is factor out that x minus 1 from this. So put the root here, put our coefficients, 1, minus 2, minus 5, 6. This is my x cubed term. This is my x squared. This is my x to the first. This is my constant. I'm going to do my synthetic division. Bring down the 1. 1 times 1 is 1. Minus 2 plus 1 is minus 1. 1 times minus 1 is minus 1. Minus 5 plus minus 1 is minus 6. 1 times minus 6 is minus 6. 6 times minus 6 is 0. We like that because we want this to be a factor. So that gives me that x cubed minus 2x squared minus 5x plus 6 is my factor, which is x minus 1 times, oh, I forgot my columns. That's an x squared column. This is the x column. This is the constant column. Remember, you lose a power when you do the division. X squared minus x minus 6. So that's a quadratic. Can we factor this? Yes, we can. X squared minus x minus 6. What are 2 numbers that multiply to give me minus 6 and add to give me minus 1? Well, minus 3 and 2. So now we've factored this into x minus 3 and x plus 2. I'm going to label this as f of x because I don't want to rewrite it a billion times. So f of x is x minus 1, which is this term, and then times that, but that we factored as this, so it's x minus 3 times x plus 2. Great. So now it's in factored form. Can we graph it? Well, we've got 3 x-intercepts. X equals 1. That's an odd multiplicity, so we'll go through. X equals 3 is an x-intercept. That's an odd multiplicity, so the graph goes through. X equals minus 2 is odd multiplicity because all of these are power 1, right? So the graph will go through at those terms. Leading term, that's my x cubed. So it's odd power positive. So odd power with a positive coefficient means my end behavior looks like that. It falls to the left, rises to the right. My roots are, I've got 1 at -2, 1 at 1, and 1 at 3. And the graph goes through at each one of those. So the graph will have to look something like, well, that's going to be at -2, 1, 3, and it ends up there. So this is 3, 1, that should be -2 over there because my drawing isn't very good. But that's what the graph will look like. And we're just really worried about which part of the graph is above the x-axis, which part of the graph is below the x-axis. Okay, so here's a 4th degree equation. Can we factor that? How can we factor that? Well, we can use the intermediate value theorem and the rational root theorem and synthetic division to factor these things. So here's our formula. What we can do is just crank out a table of values, right? So we look at this table of values. X goes from -7 all the way up to 7. We notice a couple things. First, oops. X equals 7 is an x-intercept, right? If y is 0, that's got to be the x-intercept. The other thing is y's are positive, positive, positive. So wherever y is positive, the graph is above the x-axis. And then it switches to negative between 1 and 2 somewhere. Then it's negative and comes back up to 0. So the other thing we note here, intermediate value theorem tells us there's an x-intercept between x equals 1 and x equals 2. Right? When x is 1, it's positive. When x is 2, it's negative. So somewhere between 1 and 2, it crossed the x-axis. We don't quite know where, though. Rational root theorem, what's all the possible roots? This is looking for roots of the form p over q. So this should say all possible rational roots. P, the numerator, is a factor of the constant term. Right? And the constant term is 42. So what are the factors of 42? Plus or minus, I'm just going to put these in parentheses. 1, 2, 3, 4 doesn't have 5, 42, 5 doesn't have 5, 42, 6 does, 7 does, 8, 9, 10 don't, 11 doesn't, but 14 does, 14 times 3, 21 times 2, and then 42. And all these are plus or minus, right? But I don't want to write a plus or minus for each one because it just gets tedious. The denominator, q, has to be a factor of the constant, no, the leading coefficient, the highest power coefficient, so a factor of 2. So the denominator has to be plus or minus 1, 2. So possible roots. All of these can be plus or minus. So if I take these numbers and divide them by 1, I just get these numbers again. So 1, 2, 3, 6, 7, 14, 21, 42. Those are all possible roots. And then the other roots are if this is the denominator. So that could be plus or minus 1/2. 2 over 2 is 1, but we've already got that. 3 over 2. 6 over 2 is 3, but we've already got that. 7 over 2. And 21 over 2. Note that 14 divided by 2 is 7. That's already in our list. 42 divided by 2 is 21. That's already in my list. So those are my possible fractions. So what are the roots that I think I've got? Well, I know x equals 7 is a root. And I know there's a root between 1 and 2. So which of these numbers between 1 and 2? Just this one. So I bet my roots are those two. So if I can factor those out, that'll be a good step forward in trying to figure out how to factor the rest of this. So let's factor out the 3/2 first, because I don't know if that's actually a root. It's possibly a root, but maybe there's something else, some irrational number that's in there. So we'll do a synthetic division with 3/2. And my coefficients are 2, -17, 25, -34, and 42. Oops. 42. And this is a x to the 4th column. This is an x cubed. This is my x squared, x to the 1st. This is a constant. And we will do, do a division. So how do we do the division? Pull down the 2, 3/2 times 2. Well, the 2's cancel out. That gives me a 3. Add, that gives me -14. Multiply 3/2 times -14. 14 divided by 2 is 7, times 3 is -21. Add, that gives me a +4. 3/2 times 4. 4 divided by 2 is 2, times 3, that gives me a 6. -34 plus 6 is -28. 3/2 times -28. 28 divided by 2 is 14. 14 times 3 is 42. Happy about that, right? That's my remainder column. Got x cubed, x squared, x to the 1st, constant, and that's the remainder. So remainder is 0, so that means I've got a factor. So what have I got? I've got my original function, which is 2x to the 4th minus 17x cubed plus 25x squared minus 34x plus 42 equals, well, if my root is 3/2, that means my factor is x minus 3/2. And then that's times 2 times x cubed minus 14 times x squared plus 4 times x minus 28. Great, so there's my factorization. I can do a little bit of cleaning up here. I'll factor out a 2 because all of my coefficients are even. And I'm going to call this whole thing f of x so that I don't have to write it over and over again. So f of x is 2 times x minus 3/2 times x cubed minus 7x squared plus 2x minus 14. And I know this has x equals 7 as a root. So I can divide this, I can factor out the x equals 7 by dividing this with synthetic division. So we put in a 7, 1 minus 7, 2 minus 14. Make sure I get my numbers right. That's my x cubed column, my x squared column, my x to the 1st column, my constant column. Pull down the 1. 7 times 1 is 7. Add, we get 0. 7 times 0 is 0. Add, we get 2. 7 times 2 is 14. Add, we get 0. Great. That means x minus 7 is a factor, because if x equals 7 is a root, x minus 7 is a factor. So what do we now know about f of x? F of x is 2 times x minus 3 halves times, well, we factored out an x minus 7 now. What are we left with? This is an x squared plus 2. This is my x squared column, my x, the first column, that's my constant. Okay, can I factor x squared plus 2? Well, that's easy, that's a quadratic. So how do I do that? X squared plus 2 equals 0. That means x squared equals minus 2. So what are my two roots? X squared equals minus 2. So x equals plus or minus square root of minus 2. Right? Just take the square root of both sides here. That's a equal sign, and that's a minus 2. So x equals plus or minus square root of minus 2, but we know how to handle minus signs now inside of square roots. That's I squared times 2 inside the square root. So since this is a square inside a square root, it can come out plus minus I squared root of 2. So what now is my function? 2 times x minus 3 halves times x minus 7 times x minus I times the square root of 2 times x plus I times the square root of 2. Because these were my two roots, and if I have a root, then x minus it is a factor. So if I square root of 2 is a root, then x minus I root 2 is a factor. If minus I root 2 is a root, then x minus minus I root 2 is a factor. So that's the x plus I root 2. So we've got x equals 3 halves and x equals 7 as x-intercepts. These have no x-intercepts because they are complex. So if there's an I in there, they're roots, but they're not x-intercepts because they don't correspond to anything. These are both odd powers. So that means that the graph will go through at 3 halves, graph will go through at 7. What's the leading term? Well, we go back up to the original equation. The leading term is right there. It's 2x to the 4th. It's even and it's positive. So that means our end behavior is like that. It rises on both sides. 3 halves, that's where one of my x-intercepts is. The other one is at 7. So the graph should come down to 3 halves, go under, and go through again at 7, join up with its end behavior. So that's what the graph looks like. Not to scale, I'm just trying to figure out where it's positive and where it's negative. You know, if you look at the numbers at x equals minus 7, it's all the way up at 12,000, right? So this is really not to scale. So division allows us to factor things. Now we can factor polynomials that are higher than degree 2. We can find roots by using the rational root theorem and the intermediate value theorem. And then doing some synthetic division allows us to factor these things.